GTC is for scientists, researchers, and developers whose work is so computationally demanding that it is impossible to achieve with normal computers. They seek out our style of computers because it gives them an enormous boost in the capacity and the performance of the work that they do. Over the last several years, as CPU performance has begun to slow, and yet the computational demand of their work continues to grow, has grown by a factor of 10x. It is now a global event. The number of developers of GPUs has grown by a factor of 15 times. It is in fact extremely rare. And the reason for that is because developer investment and the entire industry's investment behind a new computing architecture is incredible. New approaches and new computing architectures don't come along very often. If the performance that it delivers is only incremental, then it is better, of course, to just wait for the next generation of computers. It has to have sustainable capability that the developers in the industry needs to realize and needs to trust that it is only then they're willing to invest in porting and developing their software for a brand new architecture. They develop for CUDA because the performance is excellent. They develop for CUDA because they realize that every single year, without any additional effort, the performance of their application will continue to grow, as they realize that this architecture is literally everywhere. Getting all of these things working together until it creates a positive feedback system so that more applications drive more computer makers to make available this architecture so that more users can benefit from it. The driving force behind the GPU that made all of that happen is computer graphics, real-time computer graphics. The first is that computer graphics is computationally unbounded. It is basically recreating virtual reality. It is basically doing physics simulation. And yet, the second characteristic about computer graphics is that it is an enormously large market. No processor in the world can afford the level of R&D budget that we invest in any single generation. Modern computer graphics is nothing short of astounding. Virtual reality has been the holy grail of real-time computer graphics for a very long time. It is to create the world's first holodeck, the NVIDIA Holodeck. The NVIDIA Holodeck has several characteristics. The first thing, of course, is that it's physically modeled. It has to simulate the laws of physics. When you touch something, you have to feel like you're touching something. When you drop something, it has to fall to the ground. Because in virtual reality, like it is in reality, you have to believe that you're touching and feeling and engaging and interacting with something that is real. In this future, some of the characters will be real. They're your friends and colleagues from faraway places. And some of the characters in this world will be AIs. Let me show you the NVIDIA Holodeck.
Sean, I'm right here in the middle.
Hi, Sean.
And this is Kyle.
Hi, Kyle.
Hi.
And I'm Yuko here.
Yuko. And so, of course, they feel like they're inside this environment together. Sean, show us what you have in the holodeck for us.
Sure. Well, I mean, first, it's a holodeck, so it can be any place in any environment we could possibly imagine, so that we can explore objects with realistic lightings and shadows and get a real experience and real feel for a design. And it's the first luxury coupe from Japan.
Wow, it's beautiful.
Let's take a look inside. Kyle, why don't you hop in the driver's seat there?
Sure.
So that our car paint looks like rich car paint with multiple layers of clear coat and base coats and metallic flake if that's appropriate.
Wouldn't it be amazing if the Lexus is in a virtual world called a holodeck and all of the engineers and designers can come together and just talk about it and enjoy it together? Now here's the thing about the greatest thing about virtual reality. Sometimes you want it to obey the laws of physics. Sometimes you don't want it to obey the laws of physics. And now you have X-ray vision.
So
Every single geometry is inside this design. Now, of course, this is not a video game. We've seen video games before, and video games could be very, very beautiful. However, video games are fake. It's not useful for design. Holodeck is designed in order to make it possible for us to really create real products inside.
So it is. Okay.
Oh, you're very strong.
Yeah, I am.
Thanks a lot, guys. You did a great job.
thank you.
Thank you.
Thank you.
Auf Wiedersehen.
And that GPU is the world's most advanced parallel computing processor. In the year 2012, 3 things came together which ignited the modern Big Bang of AI. Experimenting with deep neural nets running on a GPU, and he submitted his results to the ImageNet contest, the CVPR contest. And as a result, he won the Computer Vision Image Recognition Contest of 2012. He has no special training in computer vision. And in one single stroke, he was able to defeat decades of computer vision experts. The network is called AlexNet. By today's standards, it is absolutely tiny. However, in year 2012, it was the single best computer vision algorithm the world has ever seen. GPU discovered, researchers all over the world discovered around that time, that using NVIDIA CUDA GPU could train their deep neural nets in a very short period of time. The final network was the best computer image recognition software the world had ever seen. That the three combination, deep networks, larger networks, more data, and more compute, the combination triggered and ignited the Big Bang of modern AI into natural language. What goes in as just an image could be recognized with objects and detected in the image. Really, really incredible. This software technique that I've simplified here has profound impacts on the industry, and it's the reason why we have dedicated our entire company, our full resources, to advance this computing field and build the AI computing platform. Have been incredibly busy. This is the year of Volta. Volta is the first GPU that was architected from the ground up to fuse numerical computational approaches with deep learning approaches. A computational throughput for deep learning that has never been imagined before. 125 teraflops of deep learning training performance from just one chip. It's the chip the world has ever built. Over $2 billion of R&D necessary to build Volta. This year, Volta was announced, and it is now in full production. The NVIDIA Volta, 125 teraflops of deep learning tensor core operations per second. A DGX, as well as a DGX station. A DGX is the world's first 1 petaflops AI supercomputers. DGX. We also put Volta in every single cloud. Every single cloud service provider has adopted Volta. Every single computer maker in the world has adopted Volta because they all recognize this enormous opportunity to contribute to the future of artificial intelligence. It's the largest computational problem we know today. This software stack is a high-performance computing software stack, and there are so many different types of frameworks. Every single layer of software integrated on top of our Volta, and we containerized it and put it in the cloud. It's a cloud registry. It's a container. It's a store. It's an app store, if you will, of deep learning framework software. NGC containerizes all of this complicated software and put it into a cloud registry. What is this? What did I say? Where is the car? You can ask it questions. Asking the artificial intelligence network question is called inference. The computational graph that comes out of these frameworks are incredibly complex. All of our processors, Volta, Pascal, DGX, servers, cloud, and we introduced a brand new product just last week at NIPS. This is a GPU, the Volta GPU, developed for researchers. We call it the Titan V. Let me show it to you. The Titan V is the most powerful PC processor the world has ever created. Ladies and gentlemen, this is the Titan V. The Titan V. It's available online. It's available online now for $3,000, $2,999, 110 teraflops peak, nearly 10 times the performance of the highest performance GPU in the world today, called the Titan X. The Titan X was based on Nvidia's last generation Pascal. This is based on Volta, and this is now available for researchers all over the world. Go to the cloud, whatever framework you use, register for the container, downloads it, this complicated software stack, and now you're doing AI development. When you're done with that AI development, you could run TensorRT, and it will optimize the software and make it run lightning fast. Outputs a Volta CUDA program. This Volta CUDA program was written by software. So software wrote software. And this Volta CUDA program for a deep neural network could predict many things. Depends on what you taught it to do. The performance that we've been able to achieve is nothing short of amazing. It's 140 images per second. On V100 with TensorRT, it's 5,700. 40 times the speed up. Natural machine translation, a CPU runs at 4 sentences per second, and V100 with TensorRT, 100 times faster. Remember, 45,000 images per second is not that much. And the reason for that is because you have mobile customers all over the world. And so 45,000 images per second happens all the time. And with 45,000 images per second, it would take 160 CPUs and 65,000 watts to achieve. All it would take is one server with 8 GPUs inside, 45,000 images per second, and it only consumes 3,000 watts. 3,000 watts. The more GPUs you buy, the more money you save. Very simple equation. Old way, new way. Okay? So bar chart, you cannot feel it. This, you can feel the servers. But now let me show it to you. First of all, these are flowers, of course. You recognize that these are flowers. But very few of you can recognize exactly what the flower is. Remember, the computer only sees ones and zeros. From the ones and zeros, the computer has to figure out what, first of all, that it's a flower, but more importantly, what kind of flower it is. Okay, so that's a pincushion flower. That is a love in the mist, okay? That's a water lily, I knew that. And that's a bromelia. And that is a clematis. These are flowers, these are words that has never left my mouth before. And yet, this software can recognize these flowers. They were trained to recognize these flowers, and now, for flower recognition, this software, this program, has achieved superhuman levels. That means 5 different consumers on their mobile phone can request, what is this flower? And in 1 second, this CPU will return the results to those 5 people. You might notice this is ResNet 152. This is a much more complex deep neural network. The other network that I showed you in the benchmark was ResNet 50, which is 50 layers of deep neural net. I think AlexNet only had about 12. The original AlexNet that was able to defeat every single computer vision engineer in the world, this ResNet 50 that I showed you in the benchmark has 50 layers. This neural network has 152 layers. Each one of these layers increases the ability and the accuracy of the software to recognize images. 913 frames per second, basically almost 200 times faster. Almost 200 times faster. The larger the network, the greater the speed up, the greater the advantage of the Volta GPU. But this one chip, this one processor, is making it possible for us to predict for 900 people in 1 second. This 7,000 images per second is running on 8 Volta GPUs. So what you're looking at is this. This box right here, this is the Nvidia DGX-1. There are 8 Voltas inside. This one box is doing this for 7,000 people. The more money you save. Okay, but the amazing thing is this. This is what's amazing. Remember, this is 2,000. Remember, 7,000 is that one box. One CPU is 5. 2 CPU, which is 1 server node, is 10. 1 server node versus 1 DGX, 700 times slower. Several billion dollars of R&D, enormous amounts of invention, the more money you save, okay? We could see what are the unsolvable problems. What were the previously unsolvable problems that we can now solve? It is so exciting that for the first time in all of our careers, in 30 years' time, we now see this new tool, this incredibly powerful tool that allows us to solve problems. It's called ray tracing and global illumination. What you're looking at here is on this side, each one of the pixels are slowly being rendered as the rays bounce off the surfaces, eventually comes to our eyes. But there are many black dots. The black dots is the photon has not reached it. Using artificial intelligence, our NVIDIA researchers were able to predict what is the right color. What is probably the color of that dot? And as a result, we can complete the image almost instantly. Second, NVIDIA, so we developed a network that allows us to use audio to automatically generate the appropriate animation of the face.
皆さん、こんにちは。僕の言葉を理解できますか？よかった。GTC シリコンバレーの後、日本語をずっと練習していました。どうですか？うまくなったでしょう。それにしても、ジェンセンさん、その革ジャン、かっこいいですね。
Because it has learned how to animate properly. This is using computer graphics first to create a segmentation of semantics. What is the meaning of every single pixel? And from the meaning of the pixel, we will generate a photorealistic image. Unbelievable, right? Okay, so let me just show you. This is the input. We use computer graphics to generate a segmentation and a semantics map. From this map, we create a photorealistic image. The artificial intelligence network drew this image by itself. GAN stands for Generative Adversarial Networks. It's basically a neural network that knows how to create the future, create something. In this case, we asked this neural network to create an image. Unfortunately, GANs are very difficult to control. If the GAN is too big, if the GAN is too small, the resolution of the image is too coarse. However, if the resolution requirement is very high and the GAN network is enormous, then the stability of training is very low. The more you train it, the larger the network becomes, and it's eventually able to generate every single pixel of this face. These faces do not exist. These are not real faces. These are artificial intelligence generated faces. And AI created this face. And it created these faces. Every single image, every single pixel was drawn by an artificial intelligence network. Pretty beautiful, huh? Not only is it realistic, photoreal, the resolution is incredible. And it's very realistic. Using artificial intelligence, we can now generate and create artificial humans. And we can put them into artificial intelligence created worlds. Artificial intelligence was used to do something very special here. What we did was this. IVA and NVIDIA worked together on a neural network that learned the composition techniques of traditional, classical, great composers. Beethoven. It learned classical music. So it recognizes, it knows how to generate the next note given previous notes. We gave it some new artistic styles. And the artistic style we gave it was John Williams. This, what I'm about to show you, is an original piece, never heard before score, generated by artificial intelligence. This original score is then given to a symphony. And the symphony we worked with is John Beals, the famous John Beals in Hollywood Symphony Orchestra. And he arranged and conducted what you're about to see. Enjoy, John Beal and the Hollywood Symphony Orchestra. Was able to generate this beautiful music, and working together with human orchestra, we could bring it to life. Where computers could write software by itself that is so complicated no human could possibly imagine writing. One architecture so that all of your investments in software will be leveraged across this entire base of platforms. The work that we do today will just get more valuable every single day because the architecture will continue to be backwards compatible and the architecture will continue to grow. NGC, all the software in the cloud, and it can run in every single cloud. It is multi-cloud. Amazon, Google, Azure, Baidu, Alibaba, Tencent, every single cloud. It runs on-prem and it runs on the Titan V in a PC. The most pervasive AI computing platform in the world. And I feel that it is also the most powerful technology force that has the benefit, finally the benefit of revolutionizing the industries of Japan. A cell phone can't help robotics. And the cloud can't help large, heavy industry construction. Japan is the land of robots, future. That's the reason why this is such an incredible time for Japan. This is the golden ages of IT technology. We partner with Fujitsu, the #1 computer company in Japan. Yoshizawa-san, the head of Zenrai, has worked with us closely to adopt the NVIDIA Volta into the Fujitsu servers. We're now partnered with them to bring the NVIDIA AI computing platform throughout Japan. NTT Communications is the #1 cloud service provider in Japan, has now also made available NVIDIA Volta, the NVIDIA GPU in their cloud. Is now infused with AI so that it could predict downtime in advance so that customers has zero downtime, that has the ability to teach robots how to bin pick, and has the ability to detect very minor surface defects. It was announced and shipped just this October. Incredibly proud of the work that we're doing there. PFN, Preferred Networks. A young startup with a genius CEO, Nishikawa-san, who is working on AI all over Japan. Chainer has been able to train a neural network in 15 minutes across 1,000 NVIDIA GPUs. Distributed training, was able to create and train this neural network in literally 15 minutes. But one of the most powerful new ideas is to use AIs to create AIs. And it will invent new forms of AI that is then trained and tested for effectiveness. So the fact that we can take training time down to 15 minutes is an incredible achievement, and we need it. Autonomous machines is really the next generation of AI. It's the next step of artificial intelligence, and will be the self-driving car. The self-driving car is going to change society completely. It's going to make possible, of course, cars that are easier to drive, safer to drive. We will save lives. But because of the nature of autonomous cars, long term, the car will no longer be a place that you go so that you can go to another place. Each day, we would enjoy our 1 or 2 hours of personal time inside a car. Autonomous vehicles is incredibly hard to do. However, the impact of society is gigantic and enormous. The number of applications that we have to write is really countless. Whereas the previous way of designing cars is to connect many specific functionalities into a car. The future autonomous driving car, the future car, is surely a software-defined car. The same thing that happened to the mobile industry when it went from being a cell phone to a mobile computer, from one application, just camera, to thousands and hundreds of thousands of applications in the App Store today. The same thing will happen to the car. The complexity is enormous. From level 2, where the car is basically, the autonomous vehicle is helping you drive, but you're in control, to a level 3 and level 4 car, where the car is in control whenever it knows how to drive in those conditions. The car has no driver at all. And its functionality directly affects the economics of the service and, of course, the enjoyment of the users. They need to have a scalable architecture that allows them to develop software that is largely related for a range of cars. As the sensor complexity grows, the functionality grows, and of course, the functional safety requirements continue to grow. This entire range of capabilities has to be developed in an architectural sense. The NVIDIA Drive is a supercomputer on a chip. A supercomputer on a chip. And it's able to scale to level 2, level 3, level 4, to level 5. It is able to understand the type of functionality. It includes sensor fusion, computer vision, deep learning, high-performance computing, in a very small energy-efficient package so that it's able to perform all of these different types of applications at the same time. Autonomous driving will revolutionize cars But AI will revolutionize not just driving, but also our user experience. So this car, our future cars, will have contextual awareness of the world around us, and it will have contextual awareness of us. Not just the inside of the car, not just the outside of the car. The functionality of the car will be revolutionized, but how we enjoy the car and how the car interacts with us will be revolutionized. Intelligent experience. Drive IX is an SDK that software developers all around the world could then create the next generation of user experience. This is Janine, one of our employees. And here's an example where she's coming back from an airport and she's carrying all these different bags, and she could be coming out of a shop, out of a store, and the car sees her, recognizes her face, and opens the trunk. Of course it should. There's other things that it could do. It tracks your eyes. We use artificial intelligence, deep learning, and a very special technique for labeling. We can now track eyes very carefully. And so this way, we know that as we come to a stop, that somebody who's crossing the street has made eye contact with us before we decide to go further. How do you predict the path that you're looking at, the orientation that you're looking at, just from a video? Here, we're detecting that she's being distracted. So we wrote a small application.
Distraction.
And so, if you have a car and the car's driver is required to be in control,
Distraction.
we could create an AI that allows us to remind you that you're distracted. And that, in fact, you should probably have a cup of coffee or pull over. This is Janine pretending like she's sleepy.
Attention, wake up.
So all of a sudden, this car is no longer just an autopilot, but it's also a co-pilot. The car door simply doesn't open. And so this car is not only driving for you when it can. When you're driving, it's also watching out for you. And so as you can see, the future car is just rich with software. And we need a basic computing platform that is able to do the type of processing necessary for the future autonomous machine. There are so many applications we can imagine. Every single week, your engineers are going to create more and more and more applications. You're going to put them onto the store, and you're going to download it into your car, and the car gets smarter and smarter and smarter over time. So we believe that the future car is software-defined. Xavier is the most complex chip NVIDIA has ever created. Even though this is the largest, even though Volta is the largest, Xavier is the most complex. The number of engineers that have worked on Xavier to create the world's first autonomous machine processor is in the hundreds. I can't wait to put it in the hands of autonomous vehicle partners, car companies, roboticists, autonomous machine makers all over the world. Supercomputing capability, computer vision capability, deep learning capability, rich with sensor processing abilities, all in just 30 watts. You could use one chip, one Xavier processor for your super level 2 with surround perception and all of the capabilities I've just described. You could also use multiple Xavier so that you could have more sensors, functional safety for redundancy and resiliency, or if you have tons of sensors all over the car, you could use a computing platform we call Pegasus with multiple Xaviers and multiple GPUs. Even developing the software is intensely different. For those who are already working on deep learning, you realize that the way that deep learning is done is very different than the way that software development was originally done. And then when we're done, the final neural network could be run in Xavier in the car. Data is the source code. And so it stands to reason that in the future, we need to have a rich infrastructure to manage, to track, to curate, to process, and to reprocess terabytes and terabytes and petabytes of data that we will collect. The self-driving car is the first one. It's the first and the most impactful to society of the autonomous machines we can create, but there's so many more. I believe that every single machinery that moves will have autonomous technology in the near future. So all of these different types of machines in the future will have autonomous capability. The fundamental computing is the same as a self-driving car, but the application is radically different. We believe this is going to be the next era of AI. And the opportunity to the market is quite large. $400 billion autonomous machines market, from manufacturing, agriculture, industrial, construction, to packaging and processing. The autonomous machine will scan and beam the world to the operator. The operator will operate the virtual instrument, the virtual equipment, and the commands will then be beamed back to the autonomous machine in the field, and now the two are fused together. And NVIDIA are partnering together to discover this future. Dr. Iwamoto, the CTO of Komatsu, is leading this charge to invent the future of industrial equipments. Every 2 years, IREX, the International Robotics Expo, hundreds of thousands of people come together. This year, there were 200 industrial robot companies showing robots, 150 service robots, new companies showing robots, and there were robots of all kinds, and we're doing robotic things of all kinds. So that when we're done training this robot in a virtual world, we can take the brain and move it out into a physical robot. And that physical robot will know exactly what to do. That Isaac doesn't even know how to hold the golf club and what it means to putt. However, whenever it touches the ball and the ball moves in the right direction, we told Isaac, good job. Every single time it does something smart, we give it positive reinforcement, just like a child. A little further, please. Okay. And after a while longer, wow. Wow. Artificial intelligence never make mistakes. Wow, wow. Okay. Now, you know, the green, oh wow, look at that. The green is not flat because the green obeys the laws of physics. How to put pieces of things together, how to manufacture, how to work next to us. I could be inside in a holodeck, and I could say, Isaac, pass me that screwdriver. And Isaac will go, pass me a screwdriver. And the opportunity to revolutionize the future of manufacturing, the future of industrial equipment, the future of robotics. Thank you.